Hello, this is Mr. Zanoletto again. I'm just going to go ahead and go over 11H, which is the Hinge Theorem, and 11I, which is the Mid-Segment Theorem. So the Hinge Theorem basically says if two sides in one triangle are congruent to two sides of another triangle, then the triangle with the larger included angle will have the larger third side. We'll investigate that a little bit, and then also look at the Mid-Segment Theorem, which says given mid-segments that joins, mid-segment is defined as a segment that joins the two midpoints of a triangle. The mid-segment theorem says if the segment is in a triangle is a mid-segment, then it is certainly parallel to the base that is not involved with those midpoints. So these two midpoints have these sides, and that's the base. It's going to be parallel to that base, and it's also going to be half the length of its base. So both of these, and then, like I say, it's also parallel. So let's go ahead and look at some situations involving this. And this is what I decided to go ahead and create, try to help you wrap your mind around the Hinge theorem. So we have three pairs of angles, and really the rule says that if you have two triangles and two of the pairs of sides are congruent, the included angle will dictate which one's longer and which one's shorter. I think just by looking at it you can probably see that, but if we go ahead and join these, this is a 35 degree, 2 inches on one side, 3 inches on the other, we have 35 degrees is how I created that. That's 35 degrees. I've created this as 2 inches and 3 inches. This opening, now let's go ahead and measure that. That opening, again, this was 2 and this was 3. This is going to be 1 1/2. Actually, sorry, 1 3/4. 1 1 1/4, 1/2, 3/4. So 1 3/4. So this is 1 3/4 inches with a 35 degree angle between the two sides that were 2 inches and 3 inches. Looking at the other triangle that can be formed using similar values, again this was 3 inches again, this was 2 inches. We have a 58 degree angle, which is going to dictate how far apart these are. So if I go ahead and connect those endpoints, that creates that third side. Let's see how long that is. So if I look at my ruler, that looks like about 2.5 inches. So again, this being bigger than this opens this other side to be 2.5 inches, where this only opened the side to be 1 3/4 inches. So there's a distinct difference. And if I open it up even more, just to more as a way to show what's happening here, I continue to open it. I connect these two endpoints, and I measure it. I open at 75. Now it's just over 3 inches long, 3 1/16. So 3 1/16 inches long at 75 degrees. So 75 degrees gave us a 3 1/16 inch opening, a little more than 3 inches, a little 2.5 inches, and 1 3/4 inches. So obviously, as it continues to open, with those sides being congruent, you need the two pairs of sides have to be congruent, and we're talking about its included angle. So that's very specific in nature. You don't mess with that. You have to make sure that the included angle is what we're talking about, and the sides, the pairs of sides that are involved with that included angle, are the ones that are congruent. And that does result in the smaller the included angle, the smaller the side. The bigger the included angle, the bigger the side. Okay. Then from there, I would like to go ahead and look at this triangle with regards to not the Hinge theorem, but the mid-segment theorem. The mid-segment theorem, we're going to go ahead and say this is triangle ABC, and you can't see through there. That was 5 inches. This was 6 inches. And when I measured this, this turned out to be 6 3/8 inches. That whole side. And it has a midpoint right about there. This has a midpoint right about here. This has a midpoint right about here. So those midpoints we're going to go ahead and call X, Y, and Z. This will be midpoint X. This will be midpoint Y. This will be midpoint Z. Now that mid-segment theorem that we were talking about earlier said the resulting line, if we connect the mid-segments, will be parallel and half the length of its base. So let's see how that looks. If I connect X and Y, can you buy the idea that that must be, and it's a theorem, so we could prove it. I think with rise over run on a coordinate plane, you could prove this. But yes, it will be parallel to AC. It does appear to be parallel. But like I say, you could prove it by using coordinate plane and working with rise over run and whatnot, the slope. So anyway, if this is 6 3/8, this is supposed to be 3 3/16. And sure enough, it looks like 3, 1, 2, 3, 3 3/16. So this is 3 3/16 inches long. So it is half of that. We could also connect X and Z, and sure enough, just by putting it up there, I can see this is exactly 3 inches. And looking at how these connect, they look again to be half of that, which is 2.5 inches. So in practice, we do get the mid-segments being parallel to the other two sides, and we also get those mid-segments being half of 6 3/8. Half of that is 3 3/16. Half of 5 is 2.5. Half of 6 is 3. So those rules of being half its base and parallel to it seem to hold. And hopefully you can wrap your mind around both of those theorems, the Hinge theorem and the mid-segments theorem, a little more easily after seeing us sort of dissecting that and seeing what happens there. So hopefully that helped with 11H and 11I, and have a good day. Thank you.